there's the record button. Yes, if internet goes down in America, there will be riots. At least riots at my house. Internet and cable. Whew. What would we do if we had to talk to each other? My goodness, right?
Mine too. My kids will like literally kick me out because it's funny because the Netflix thing had expired the other day and I was at work. My kids called me like 14 times, I swear.
Netflix is down.
Yes,
Oh,
like,
yeah.
hey, can you pay the Netflix now? And I'm like, geesh, I forgot.
Can you do the last step again? X equals 1 minus. I saw
Okay.
the margin of error is 3%, and then what?
So what I'm finding here is alpha, not X. I'm sorry, that's a bad, that looks like my X's, doesn't it? So I'm finding the alpha that we need to calculate this critical Z value.
Okay.
So alpha, I should remind you of the formula, is always 1 minus the sea level.
Yeah.
So here was our sea level, 0.95.
Oh, 95. Okay.
Good. And then we wanted half alpha for the Z critical value. So I
So
divided each of these.
0.025. Got it.
Nailed it. So then we're going to write this here, 0.025. And we don't have to show our work like we did back in 9.1. We just have to find it. So I'm going to hit second variables to get the distribution. So remember Monday we did inverse T when we were working with mu's. We're now doing inverse norm because we're finding a Z critical value. Remember mu is 0, standard deviation is 1. There it is, 1.96. Now it says negative. Notice we're going to square whatever's in here. So we really want the positive one, but it doesn't actually matter. Okay, we have everything we need. We've got our Z alpha divided by 2. We've got our E, and now we just plug it into the formula and calculate. Unfortunately, the calculator does not have a function to do this, so we have to do all of this by hand. We have to do it ourselves. So there's the formula, or the numbers in the formula. I'm going to get an approximation for this first. So I'll do 0.25 times 1.96 divided by 0.03, close the parentheses, and then the squared button. And I used this squared button, but you could also use this caret and the 2. Hit enter, and you get 1067.11111 forever. And then recall we have to round up.
Hey, Eric.
Talk to me.
Isn't it supposed to be 0.025?
So for this one, this should be 0.025. But in the formula, it should be 0.25.
Okay.
That makes sense? Yay, Ramon, I'm glad you're here. How's everyone feel with this? My daughters are about to break in.
Hold on, I'm still doing it in my calculator.
Okay, yeah. I'll wait. I think for the first time in 5 days, I showered and I put on dress clothes, and it feels amazing. Every other time I've been in here like stinking up the room in my PJs, and it's so much better when you're pretending like you're going to work, right?
Okay, I got it. Thank you.
Awesome.
Will these be uploaded in the same spot as the other ones?
Say that again.
Sorry. Will these be uploaded in the same spot as the other ones, like on?
For the video, yeah, yes, it'll be in JetNet.
Okay.
Actually, yeah, it'll be in JetNet and maybe even in Mystatlab. Thanks, Emma. Okay. Tears. Let's do the second one. So this is the same problem, except notice we said, suppose we had the results of last year's poll. So this is a prior result. And we found that 67% of students thought that JC professors were awesome. So that means our p hat is 0.67. Note, we're going to keep the confidence level the same and the margin of error the same. So we're going to reuse this Z alpha of 0.025 from above. And our E, which is 0.03. And now our formula is N equals P hat times 1 minus P hat times the Z critical value divided by E squared. And let me pause that. By the way, back up here, we should have said students, because that's who we're surveying. Okay, so I'm going to put all the numbers in, and then we'll run it through the calculator. So we got 0.67 times 1 minus 0.67, all times 1.96 divided by 0.03 squared. Oops, I don't know why I bracketed it that. And I am getting 943.75 approximately. Which the correct answer is 944 students. So notice it's less when we have a prior estimate. And if you look at how we calculated this number, we're multiplying times the critical value divided by the margin of error. This is a 50-50% is what that is. 0.25 is 50% times 50%. So any other number, any other prior estimate is always going to cause our sample size to be smaller, which is nice because we already kind of have an understanding of what it should be. So anytime you're using this formula, it's going to be smaller, a smaller sample size than when we were using the no prior estimate. And if you think about what that means, you're saving costs because it costs money to survey people. Well, that's what this note is. So when a prior estimate for P is available, it means the required sample size is smaller. Okay. The 9-4 worksheet's a really great worksheet to practice this, by the way, and I'm guessing you're going to do that tomorrow in class. So if there's no questions, we'll do another.
Oh, I got a question.
Oh, please.
So I want to make sure I got this right. Excuse me. So without a prior estimate, the sample size will be larger. With the
Yes.
prior estimate, it will be smaller.
Yes.
Okay. Thank you.
You're welcome. Yep.
And yes, Eric, they will be doing 9-4 worksheet tomorrow in class.
That's what I thought. You all don't miss that. That's going to be a good one. Okay. Here comes this the same thing, the same process, except we're doing it for a mean. Now, note something. See how there's a Z alpha divided by 2 in here? If you recall, we used T critical values to calculate the confidence interval, but we're not using T critical values to calculate this. And one of the reasons is to do a T critical value, we had to know the sample size in order to get the degrees of freedom. So here we're just trying to calculate the degrees of freedom, so we can't use a T critical value to do that. So that's something you might want to note on like a, I don't know if you're all making a reference sheet, a note to yourself that when you calculate the sample size for a mean, you still use the critical Z value. So in this formula, I think you should recognize everything. This E is the margin of error. This S is the sample standard deviation. And then the Z critical value. So Let's do it. I can never pronounce this word. Onondaga Nation, maybe, or not, something like that. They live in this county, New York. So we want to estimate the mean annual income. So this word right here is what tells us we're working with a mu, which I didn't do that back here on the previous problem. Boy, where did it say proportion up here? I guess this how many students implies a proportion. And then down here, anytime you see a percent, that's guaranteed a proportion. Is what you're working with. So here we actually put all the
Can we
work.
say that part again?
Anytime you see a percent, I'm glad you asked me.
Percent is always a proportion.
It's always connect, yes. Yes. Although we should be a little careful here, the margin of error was also a percent, but that's because we're working with a proportion, so we're still good.
Well, I mean, that was so anytime there's a statistic, it's the proportion, right?
Yes. So thank you, T. Yes. A statistic with a percent, or that is a percent, equals proportion. You're always going to get a confidence level that's a percent, and that is not a proportion that we're talking about. So means will have that 95% in them. Okay, so yeah, here we go. How large is the sample required if we want our estimate to be within $1,000? And here's that confidence level, 98% confidence level. Notice up above, we were told that the standard deviation of their incomes from a sample we drew was 20,000, or from a previous sample. So we're going to write down this. That's the formula. We need our S, which is the 20,000. We need our E, which is the 1,000 from here. How did I know that? So if we want it to, our estimate to be within, I think this is the key, within $1,000. And then our Z alpha divided by 2, so we need to figure out what's our alpha. That's 1 minus our confidence level.
So it's 0.005.
And then you need to cut that in half. 0.01. Because 1 minus 0.98 is 0.02. And then
Oh, I did that wrong, yeah.
Okay, good, good. So we are calculating this in our calculator. Inverse norm, 0.01, bam, 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 0.1 for all that mess. And negative, which really we want it positive, doesn't actually matter, 2.326. So you have to be careful with Mystatlab and see, rounding this to not enough decimal places will change what n is. So I'll try to open up Mystatlab and see how they ask these questions, because it would be easy to get these wrong but do it right. Like we could do this as 2.33, and that's going to change this by a couple numbers. Okay, so we've got our 1, 2, 3 things that we need. Let's plug them in and let the calculator spit out the value for n. So 20,000, and then the 2.326 divided by 1,000 squared. I had my class last night. My professor did Zoom, and he was like yelling at people to respond. It was really funny. I felt his pain. This is what I get.
So it's
Which-
2,165.
That's it. That's it. And this isn't people that we're looking for. These are annual incomes, which corresponds to people, but whatever. Okay, how do y'all feel about that? Oh, there's only 4
How?
questions. Go ahead.
How are we going to know what the not standard deviation, the margin of error is?
It is always going to have to tell you.
Okay.
So you're always going to have to be given like this 1,000, or in the previous question, within 3%.
Oh, so it's the within.
Yes. Yeah, it'll
Okay.
come from the within. So here's let me share my screen. Here's an example of my Mystatlab question. So a doctor wants to estimate the mean HDL cholesterol of these 20 to 29-year-old females. How many subjects are needed to estimate the mean, whatever, with a 99% confidence, assuming S is 14.7 based on earlier studies? Suppose the doctor would be content with 95% confidence. How does it decrease? So for this first one, we want, we're going to use the same formula we just did. And then alpha is going to be a 1 from this. So we'll cut that in half, sorry, 0.01. We'll cut that in half and you get 0.005. And then you'll run it through the formula. And let's see, let me just do this real fast. So inverse norm, I'm doing 0.005. My zeta critical value is 2.576. So I'm going to do 14.7 times 2.576 divided by, notice it says within 4 points. So that's that 4 right there. There's the within T was talking about. There's your E. So I get that this is supposed to be 89.62 something, something, something. So we should say 90 here. Let's see if I'm right. Hey, that feels good. And then you repeat, do the same thing, except that we're changing the confidence level. What do y'all think about that?
I was a
Need
smidge,
to practice more. I don't get it.
yeah, I was a smidge distracted. I didn't understand how you found that at all.
Okay, let me, yeah, well, I didn't even, I didn't write it. So remember, it said a 99% confidence level. It gave us a standard deviation of 14.7, and it said we needed to be within 4 points. So that was our E. So these are the only 3 important things I need from that problem that we were given. And so then it says, how many subjects do we need? Well, we need to use the formula N equals S times Z alpha divided by 2, all divided by E, all of that squared. So I have to identify these 3 things, then plug them into my calculator and we're done. Well, they gave us S right off the bat. They gave us E, you just had to be careful and note that it was that 4. And then the alpha here is 1 minus the confidence interval amount. So that's 0.01, but note we want half alpha. So we divide all that mess by 2 and you get 0.005. So what I need then is this, Z with an alpha of 0.005. So I go to inverse norm. There I had plugged it in already. And I get negative 2.5758 something, something, something. Let's just round it. I think 3 decimal places are going to be okay when you do Mystatlab. That's what I used. I think if you do 2 or 1 decimal places, you're going to be wrong. It'll count it wrong. Okay, so I have my 3 things, 1, 2, 3. So this will become 14.7 times 2.576, all divided by 4, and then we'll square them. And what I got when I typed all that in was 89.62. So we round that to 90 subjects, which is what my math lab took as an answer. Yeah, so if we'd only done 2 decimal places here, so if I'd made this 2.576 a 2.6, the answer would have been 92, which if I was grading and I saw you rounded to that, I would have counted that correct. But my math lab or my stat lab would not have. So give at least 3 decimal places for this. Is that a little better?
Yes, thank you.
Or do we have to put it in parentheses when we doing this, or no? Because I
So
see
if
you
you
didn't
look at
put it
what
in
I did,
parentheses.
I didn't, because what I did is I typed in this part that's inside the
Okay.
parentheses. I hit enter, and then I
Okay.
just squared that.
Okay, all right.
But you could put it all in parentheses. And it'll directly give you the number. So either way. And then that Mystatlab question had another one. It then said, do the same thing for 95%. So all of this stays the same. We just have to change our alpha, which then changes our Z alpha. Okay. Let's now look at the connection between the margin of error and the size of the confidence interval. So that's what we're going to do here. So I think this is probably really good practice. I'm going to give you a few minutes to do this yourself. I'm giving you an X bar, an S, and an N. So a mean, a standard deviation, and a sample size. And I'm giving you a confidence level, and I'm wanting you to just get a confidence interval, get 3. Notice we're leaving the mean and the standard deviation the same. We're leaving the C level the same, and we're changing the sample size. And our goal is to see what happens to this confidence interval as we increase the sample size. So I'll do the first one, and then I'll let you do the next 2, and then we can compare our results. So to do this, if you recall, to get a confidence interval, you hit stat, you go over to tests, and this is a T interval because we're working with a mean. Now we don't have data, so we can't use this one. We have statistics, and what we're going to put in is the X bar, which is 350, the standard deviation, which is 100, and the sample size here is 50, and my C level is 0.95, and we're just going to have the calculator spit out the answer. And the answer here is 321.58, 378.42. So that's the confidence interval. And what we want then is to calculate the margin of error. Recall that the margin of error is half the width of the confidence interval. So we can find this by taking the upper limit, which is this one, subtracting from it the lower limit, which is that one, and dividing all of that mess by 2, and this gets us the margin of error. So 378.42 minus 321.58. I hit enter, divide by 2, I get 28.42. Okay, so you try that for the next 2. And I'm going to force myself to wait by going to get some coffee. Was that enough time?
No, I gotta finish my last one.
I'll keep waiting.
So this may be a dumb question, but how do we know the whole roundup thing and how it's different? And I don't know.
Not a dumb question.
Okay.
So you always round up when you use these sample size formulas. Always, always, always. When you're creating confidence intervals or any other thing you do in this class, you're rounding using the laws of rounding or the principles of rounding. Like if I was to round this number to the nearest whole number, I would make it 322 because of the 5. And I would make this 378 because of the 4. The reason you round up here is because to get exactly within the margin of error of 4 at this confidence level, we have to have exactly 89.62 subjects. But you can't have 0.62 of a subject, so we have to make this 90 subjects. And even if this was 89.12, we still can't get 1/2 of a subject. It wouldn't be this confidence level at this margin of error. So having more subjects will guarantee that you're within this amount. Having less makes you fall away from that. So that's why you always add 1 to your sample size, unless it's exactly 89.0000. I don't know if that helps.
Yeah, thank you.
Good. Okay, so I'm gonna start putting in these confidence intervals now. I just have to go in and change the one thing. Did you all get 333.87 and then 366.13? Good. What happened to the lower limit?
It went up.
And what happened to the upper limit?
It went down.
So if you think about what's happening, here is the first confidence interval. And then when we increased the sample size, the lower limit went up and the upper limit went down. So what happened to the width of the confidence interval?
It got smaller.
That's it. That's exactly it. Yep. Okay, so I guess we got to get one more here. In general, if you increase the sample size, you are going to decrease the width of the confidence interval. The last one is 337.54, 362.46. So this is even smaller than that, and this is even larger than that. So we've brought in that confidence level even more. So in terms of margins of error, I'm just going to type them. I'm assuming you all got them, right? Oops. 16.3 for this one. And 12.46 for the last one. So another way to note numerically, recall that this is twice or half the width. So we've decreased the margin of error when we increase the sample size. So here's a logical explanation for that. If I want to know, say, what's the mean score of our class on, say, exam 2, and let's just, for whatever reason, I took a sample of 10 students and I calculated that mean score and I would create a confidence interval. Well, if I then took 15 students and calculated the mean, I would have a much smaller confidence interval because I would have had more of the class in my sample. In fact, if I took all of the students in the class and calculated the mean, I would know the exact mean. So the closer our sample size gets to the size of the population, the smaller our confidence interval, because we're actually getting closer and closer to calculating the parameter itself. So that's the logical reason of why it's happening. We should write down what this does. Increasing the sample size decreases the width of the confidence interval. Now, if you look at the formulas, the place where the sample size comes into the calculation is right here. So we're dividing by the size of the sample. And I don't know that we really explain this, or that I ever explained this to you. This piece right here, that plus or minus piece, this is the margin of error. And of course, this piece here is the point estimate. So if you take a number and you divide it by a larger number, what happens to it? In other words, 3/4, 3/16, 3/32, 3/1000. What's happening to these numbers as I make this larger and larger and larger and larger?
Numbers should, are they decreasing?
That's it. That's it. Yep. So this number is getting, the number itself, the entire number is getting smaller and smaller and smaller. So that's what's happening here. As we increase this sample size, the number that we're adding and subtracting from the point estimate is getting smaller and smaller and smaller and smaller. So it's causing the confidence interval to get closer and closer and closer together. So it's decreasing that width. We should put in here also the margin of error. The two are intimately connected. They're essentially the same thing, right? So why does it make sense? We are dividing by the sample size. So here's the relationship. Increase in decreases the CI. Or vice versa, decrease in increases the CI. It's a teeter-totter. So if we put N on one side and the CI on the other side, if we make this go up, then this will go down. If we make this go down, then this will go up. And that's the relationship between sample size and the confidence interval. We have one more relationship to find, and then we're done with chapter 9. Okay, same thing as we did here. Same exact thing. Notice we're now using P's. So we're using proportions. I'm giving you an X and I'm giving you an N. Recall that P hat is equal to X divided by N. So these are all 40 over 100, which they're all 0.4. So I'm fixing the P hat, the point estimate, but notice I'm now changing the C level. So I'm starting at 80%, then 90, then 199. And I just want you to calculate 3 confidence intervals just like before. Let me remind you which test to use, and I gotta make sure I remember it too. It's the one prop Z test, the one proportion Z interval, I mean, one prop Z int. So option A in your calculator. And note what you need there is the X, the N, and the C level. So this one is 0.3372, 2, 0.46278. That's the confidence interval. If I want the margin of error, I do the exact same thing I did in the last problem. Take the upper limit, subtract from it the lower limit, and divide by 2. and I get that my margin of error is equal to 0.06278. So you all do the next two, fill those in. It's good practice of using the calculator to get a confidence interval. I'll do some push-ups while you do that. How y'all doing? You got it? Hope I'm not rushing you. Did you all get 0.31942, comma 0.48058?
Yes.
Good. What happened? What happened to the lower limit compared to the previous one?
It went down.
That's it. So if this is the first one, what's happened is we've had to make the lower limit smaller, and note the upper limit went
It
up.
went up.
Nailed
Yeah.
it. So what happened? Say it, Theo.
So the width, I just had it wrote down. Okay, so the width of the upper limit went up and
That's it.
the width of the lower limit went down.
So the width in general increased, meaning we've created a wider confidence interval by increasing our sea level.
Yep.
Good. Okay, one more just to nail this down that this is definitely true. It's going to end up larger, and then I'll talk about the logic of it. Oops. Oh, come on now. I had it and then I deleted it. So the last one is 0.27381, comma 0.52619. A smaller lower limit than the previous two, a larger upper limit than the previous two. So we've had to increase the width even more. And you can see that happening here in the margin of error.
So with that, do we put 0.99 in there for that?
Yes, yeah, this would be a
Oh.
0.99.
Okay.
Yeah, you should have put in 0.8 here, 0.9 here, 0.99 there. Good.
Okay.
Okay, so in general, how does changing the confidence interval, what does it do? So increasing the C level increases the width of the CI, the confidence interval. This one's a little trickier to see why with the formula. So what we have to think about is, what does the C level affect in the formula?
The width?
Yes, but which of these 4 variables are affected by the C level? And it's kind of obscure. I'll remind you that alpha equals 1 minus the C level. So what happens is, as we make this C level larger and larger and larger, it makes alpha smaller and smaller and smaller. And if you recall what alpha is, it's the right tail area. So if I have a really tiny alpha, it's going to make a much larger Z or T critical value. So this is a small alpha. And like if I put my alpha here, this is a large alpha. And recall that this is like a on the x-axis value. So we start at 0, and then, well, I shouldn't put alpha there, should I? I should put alpha here, and I should put alpha there, and then we'll call these like Z alphas. They could be T alphas. So this Z alpha is going to be a smaller number than this Z alpha. And the same thing is true for the T's. So when we multiply by a number that gets larger and larger, what happens to the number we're multiplying at times? That number itself gets larger. So if we have like 3 and we multiply by 2, that becomes 6. If we have 3 and we multiply by 10, that becomes 30. If we have 3 and we multiply by 100, that becomes 300. So in other words, what I'm saying is, these Z's and T's are this number that we're multiplying by, and then this thing is more or less fixed. So as we make this alpha smaller by increasing our confidence level, it increases what we're multiplying by, thus makes this margin of error larger. That's the algebraic thing that's happening. So why does this make sense? The C level changes the critical values. So that's T alpha or Z alpha, depending upon which one we're working with. And we multiply by the critical values. If that's like really confusing, don't fret. It's essentially this: increasing the C level increases the confidence interval. Now, let me say something that will make sense. If I want to be more confident about my estimate of the population, all I have to do is increase the possibility of options that the parameter could be. So for example, I am 100% confident that the mean grade that you all will get on exam 3 will be between 0 and 100%. And I can say I'm 100% confident because those are all of the possible values. So when we make the confidence level larger and larger and larger, we're including more possibilities for what the parameter could be. So if we want to be more confident, just make it wider and we'll catch more things. It's like fishing. If you throw out a bigger net, if you're fishing with a net, you have a higher chance of catching fish than if you used a really small net. So that's what this is doing. Increasing this confidence level makes that confidence interval wider and wider and wider. And you can see that doing that, at some point, your estimate of the parameter is useless. Like, it's not useful for me to say that the mean score for this class is going to be between 0 and 100, because those are all of the options. I'm not really saying anything. So at some point, you have to balance what confidence level do you want with what kind of answers, what kind of information are we going to get from that confidence level. All right, what do y'all think? Is that okay?
Yep.
Yay. All right. Congratulations, you've completed chapter 9. So 9.5 is this really fun, like, hey, can you go back through and fill out everything we just learned? So these are the two confidence intervals we're working with. The statistic or the point estimate for each are these. The parameters are these, and I'm going to stop here because I think it's really useful for you to fill these out yourselves. And then we can, on, what is it, Monday, we could go over your answers. You could share your screen. You could also watch Alana's YouTube video. She has this all typed out and filled in for you. But I think this is a good summary of confidence intervals. And this is a really good summary of what we just did here. Here's the 3 formulas to calculate the sample size. And then the parameter we're working with here, I'm just going to note it for you on this one, PP and mu. So this is really good practice. And then the worksheet for 9.5 is like a must for practice. I almost think I should make you turn it in, but I'm not going to. And so if you all don't have time to do it with Cindy, we'll do it together on Monday because I think it's that good. What it does is it puts everything in the chapter together on one sheet. So you have to figure out, is this a proportion I'm working with or a mean? Actually, should we do it now? We have tons of time. We could do it right now. Or would you rather look at some more Mystatlab questions?
Statlab.
Okay, StatLab. Is there any specific StatLab questions that you'll want me to look at? Or should I just grab a random one?
Just something chapter 9.
Okay, I'll do a 9.5. Oh, it says I have to what? Oh, good, I got away with it. So I'll do number 9.5, question 6. Okay, so let me share my screen. Okay, so here's the question. And it says, let's see, people were polled on how many books they read the previous year. Initial surveys indicate that the standard deviation was equal to 15.6 books. We're going to complete parts A through D. Lovely. So I don't know if you've all seen this. There's these Z critical values. What this has done for you is they've calculated the critical values for a 95% confidence level, a 90, a 95, and a 99. So
Hey, Eric.
Talk to me.
I'm trying to get in the stat lab and I'm trying to do the homework, get into the 9.5 homework, and it says I have to score 100% on the something else.
Oh, click the 9.5 lecture.
Yep.
And then close it, and you'll be good.
Okay.
That 9.5 lecture is a link to a YouTube video of Alana filling out what I just showed you, all those 9.5 in your notes. So what's helpful about this, number one, is we don't have to use our calculator to find these Z-scores. And number two, this is the numbers that they're using to calculate this in the formulas. So that way we will round to the correct number that they want. Notice they're all 3 decimal places. Okay, so A says how many subjects. Now, anytime you see how many, that means you're using a sample size, not a confidence interval. So I'm gonna unshare my screen, I think. Yeah, here we go. And I'm gonna write down the pertinent information from that. So we wanted a 95% confidence level. This is number 9. This is 9.5 from Mystatlab. This is number 6, question A. So our C level for the first part is 0.9. Note they said that the standard deviation was 15.6. Oh, did they give us a margin of error? Yeah, here it is. Okay, I better show my screen again so you can see that it was kind of hard for me to find where the margin of error was. So here it comes. So it says how many subjects are needed to estimate the number of books read the previous year, and just like T said last time, within 6 books. So there is the E, or the margin of error. That's 6. All right, how do we feel so far?
Okay.
So what we need then is the formula. So which of these 3 is it going to be? Well, since we're working with a mean, there's only one formula for it. It's this one. So I'm just going to write that formula down so that we can do it. So n equals s times z alpha divided by 2, all divided by e squared. So our alpha is 0.1. Our half alpha is 0.05. And what we need is z alpha 0.05 to finish this calculation.
Wait, why did you use that formula? Why didn't you use the one that says no prior estimate?
Great question. Let me go back to the problem so I can show you, or let's see, share my screen. Too many screens open. Okay, here we go. So the reason I knew is because it said how many subjects are needed to estimate the mean.
Oh.
The other clue is...
Oh, that's me. Got it.
Good, good. There's one other clue. The only formula that has an S in it, a standard deviation, is the formula for the mean.
Okay.
Cool. So 0.05, bam, 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 bam. It is 1.645 is our Z value. All right, we have everything we need. Let's plug the pieces in here and away we go. And then we'll see if I actually got it right. That's the fun part. Oh, I should have put in my parentheses. I got 18.2927 something, something, something. Does that seem right? Yeah, I think we're okay. So that means we need to round this to 19. I'll pause there for a moment. And now I'm going to share my screen and let's see if I got it right. Ah, that feels good. Okay. So note they're saying now how many subjects are needed to estimate the mean number of books read the previous year within 3 books. So everything else in the formula is staying the same. We're just now dividing by 3 instead of 6. So I'm going to go back in my calculator and I'm going to select where this formula was. And where there's a 6, I'm going to change that to a 3. And this would become the new answer, 73.17. So I'm seeing that as 74. So let me share my screen again, and I'll type in 74. If you all are doing this yourselves, you
Oh,
probably
wait, what did you do to the calculator?
let me show you. So I hit the up button. So this was highlighted, that previous place where I got the 18.29.
Mm-hmm.
And then I hit enter, and then it copies that down, and it allows you to like scroll through it.
Oh, okay. I just did that, and then I changed a 6 to a 3.
That's it. And then hit enter. Yep.
Oh.
Then you don't have to retype everything. Okay.
Oh gosh, I hit clear and it cleared the whole thing.
Oh no.
Okay, what do I do to get rid of that 6 again? I'm sorry.
Just did you select it so that you have this showing, right, with a blinking cursor?
Yeah, it just selected the 6. It don't have the whole thing.
Well, then you could just retype everything. If you don't have the entire thing you
Okay.
typed out, you're just gonna have to retype it.
Okay.
Because you have to select the entire thing.
So B, you changed the 6 to 3.
That's it. Yep. And I'm imagining if you all have yours open, you probably have different numbers for everything.
Okay, thank you.
You're welcome. Okay, so let's go back and check the next number. So my 74 was right. So what effect does doubling the required accuracy have on the sample size? Okay, so if you think about what happened, here we wanted to be within 6 books, right, for the first one. And the second one, we wanted to be within 3 books. That's a doubling of the accuracy because 6 divided by 2 is 3. I don't know if that blows your mind or not. We want to be twice as accurate, so we want to be within 3 books instead of 6 books. So if you look at what happened, doubling the accuracy increased the sample size significantly. So doubling the required accuracy nearly halves the sample size. No, that's not true. Nearly quarters, that's not true. So quadruple means times 4, and double means times 2. So 19 times 2 is what? That's 38, and 19 times 4 is 76. So it almost quadrupled the sample size required. So I'm going to check that answer. Yay, that's correct. Last one. So now, note how many subjects are needed to estimate the mean number of books read the previous year within 6 books. So it's the same margin of error as letter A, but we're now wanting to increase the confidence level to 99%. So all that means is it changes our alpha. Well, this little thing that Mystatlab gave you is a nice handy way to real quick get the number. We started with a 90 at 1.645. We're now changing that critical Z value to 2.575. So let me show you what I'm going to do in my calculator. I did the same thing you did, and I hit clear. Well, here we go. I can go back to this one. So we're changing this 1.645 to 2. Oh boy, now I'm forgetting it. 545, is that what it was? 2.575, and this needs to be 6. Okay, let me write down the formula for what we've done. So at a 99, oh, I can't see what I'm showing you all. Here we go. So at a 99% confidence level, we're changing the Z alpha to 2.575. Our E was supposed to be 6 books, and our S is still 15.6. So what you would type in your calculator, and what I did was just save myself time by selecting the previous one, which you don't have to do, is 15.6 times 2.575, all of that divided by 6, all of that squared. My calculator is giving me 44.82, so I should write that as 45. So I'm going to share my screen again so you can see me put this in and get it right. Did I close it? Well, I can't find which screen to share. I don't know. Maybe it's this pop-up. Let me try again. Yeah, that was it. Okay. So I am typing in here, what did I say? 45 subjects. Yay. So how did increase in the level of confidence in the estimate affect the sample size? Okay, so if we compare this 45 to the previous 19, it increased it, right? So by increasing the confidence level, we had to increase the sample size. And if you look at the relationship between 19 and 45, that's almost double. Remember, 19 times 2 was 38. Let's see, 19 times 3 is 57. So it's almost doubled. Let's see what our options are. Increasing the level of confidence increases the sample size. That's true. So for a fixed margin of error, greater confidence can be achieved with a larger sample size. That's the answer we want. All right. Yay, I have 100% on one of the questions. What do y'all think? Does that seem good? Let's do this one. Can you all see the screen? Okay, so this question says, simple random sample of size 40 is drawn from a population. The sample mean is found to be this, and the standard deviation is found to be this. Notice the word construct. That's a command. Construct a 99% confidence interval for the population mean. So it didn't say how many, so we're not looking for a sample size. It said construct, so we're creating a confidence interval. And if you look at this one, Mystatlab is asking you to enter the lower bound, and my guess is the next one is going to be the upper bound. So I'm going to unshare my screen, and I'm going to write down all this information that we just were given. So we have an n equal to 40. We have an x bar equal to 121.8, and we have an s equal to 12.3. And then we want, our C level is 0.99, so our alpha is 0.01. So what we need to figure out is which of these two formulas do we need to use to create the confidence interval. And I know it's this one, because we're creating a confidence interval for a mean, not a proportion. Also, notice this is the formula that has the x bar in it and the s in it. This one doesn't have it. So there's kind of a lot of clues as to which formula to use. So I'm just going to write that formula down on this side, even though we don't need it. X bar plus or minus t alpha divided by 2, s divided by the square root of n. So the only other thing we need here, even though we don't actually need it, but if you were doing like a worksheet or a paper quiz, is the half alpha and then the t value that corresponds to that. We also need the degrees of freedom. Recall the degrees of freedom are equal to n minus 1, so that's 39. So this is what we need to find in our calculator. For this problem in Mystatlab, we don't actually need to do this, but I want to make sure you understand how to do this for when you're working on the pre-do. So I need second variables. I need option 4. I'm putting in the 0.005 for the area and the 39 for the degrees of freedom. And wait for it. There it is. 2.708 is my critical T value. Now, to get that confidence interval, though, all we need to do is hit stat, wrong button, stat, go over to tests, and let's see. This is a T interval. So we're going to put in 121.8 for the X bar. By the way, note we have to put in stats because we don't have a set of data to put in. 12.3 for the standard deviation, 40 for the N, and 0.99 for the confidence interval. And there is, or sorry, for the confidence level, and there's our confidence interval, 116.53, comma, 127.07. Is that good?
You went so fast. You lost me a long time
I
ago.
thought I was going fast. I kind of thought so. Okay, where did I lose you?
Let me see. Oh, when you go in to put the first data in and before you get to the last thing.
Okay, so we're doing T interval under tests. So we hit stat, went over to tests. We're selecting option 8, so you had to scroll down a little. When you first got in there, you stat tests. It's the one right below the 7. Hit enter. If you were on data, you can't use that because we don't have a list of data to use. So you have to go over to stats. And then you're going to type that mess in. 121.8, 12.3, 40 for N, 0.99 for the C level. I think the only one that it looks a little weird is the calculator uses SX for F. And then calculate. And there it is. Is that better?
Yes, you got the T level to 0.005. Where'd you get that from?
So the confidence level was the 99
Mm-hmm.
from the problem. So the alpha is 1 minus that. That's where I got this 0.01. But then I needed the half alpha. So I divided by 2 to get that.
Okay.
Now, did you notice nowhere in the calculator did we type that in?
Right.
So in terms of what we have to input for Mystatlab, we didn't have to find that at all.
Okay, so 1 minus 0.99 is 0.01. Okay.
So Theo, remember when we were doing these and when formula substitution and result, and we were talking that if you really do it in StatLab, you really don't need to do all that you can just do the other part. But like Eric was saying, for pre-do, it's probably going to ask you for formula substitution and result. So we do have to find that critical Z value. Is that correct, Eric?
Okay, shall we see if we got it right?
One more question, Eric. I'm getting
please.
some reminds. Can you let them know when the pre-do and the project number 2 is going to be due?
Yes. And I think I told you the wrong date.
Yeah,
April 7?
I haven't answered that yet. I was going to wait and have you tell them.
So according to my schedule, we should be ready for exam 3 on April 21st. So that's 2 weeks after this week. So sometime within that week, you're going to have the online exam available that you're going to have to take and complete. And then you're going to have to send me a PDF of your answers to the exam 3 pre-due sometime that week. So that's April 21st. And then that project is going to be due at the end of the semester. That's probably going to be a significant portion of your final exam. So that would be due May 6th. And I'll post that as an announcement in Mystatlab to make sure everyone remembers. Okay, so I'm going to put in that lower limit. Notice it calls it lower bound. We've been calling it lower limit. So that should be 116.53. I wanted to make sure we checked. Notice it says 2 decimal places and my calculator only gave 2. So that's good. Yay. And then the upper bound, which is the upper limit, 127.07. Yay. So only 4 questions left on that homework for 9-5. By the way, you're now ready to take the chapter 9 quiz. So you kind of have a lot due on Monday. If you were behind, let's see, chapter 8, so 8.1, 8.2, and 9.1 got moved to this Friday as a due date. And then 9.2, 9.3, 9.4, 9.5 are all this Monday with chapter 9 quiz, or the chapter 9 quiz and the chapter 8 quiz. Let me double check that that's right. And again, like if you all are getting swamped and things at work, let me know. I think I'm going to individually change due dates if you're getting swamped, because I'm a little worried, like if you're procrastinating, you're going to get way behind. If you're not procrastinating, it's just work, I want to be very, helpful in that, if that makes sense. So yes, according to what it says in my math lab, actually I made everything do the first. Oh, that's today. So today you have 8.1, 8.2, and 9.1 due, and then on the 6th you have 9.2, 9.4, and 9.5 due. And then as for the quizzes, you have chapter 8 quiz due on Monday and chapter 9 quiz due on Monday. So I'm going to leave those in for now, just to try to keep you working and focused. And then you all just email me if you need more time. Other questions, concerns, things on your all's minds?